6.5a, operations with radicals. They basically were just adding like terms. So if you look at problem number 1, square root of 5 plus square root of 5, do not say 5 plus 5 is 10. All right? It's kind of like saying x plus x. If you had x plus x, you would say that's 2x. It's kind of the same thing. It's something plus that same thing is 2 of those things. So you can think of it like 1 of these plus 1 of these equals 2 of these, and that's literally all there is to it. That's it. Okay? So it's kind of like you're adding like terms. So it's exactly like you're adding like terms. If you said negative 3x minus 2x was negative 5x, that's what you're doing in this problem. You're saying negative 3 of these things minus 2 of these things is negative 5 of these things. It's all about like terms. Sometimes people miss a problem like number 5 because they don't realize there's a coefficient of 1 right there. But this problem is essentially the same thing as saying negative 2x minus x minus x. That's going to be negative 4x when you add those like terms together. It's negative 4 of those things. So negative 2 minus 1 is negative 4 of those things. We don't even have to do anything with the 5s. Was there a question? Was there a question? All right. Now number 7 is the first one where we've got a 2 and a 6. We've got things that are not like terms. It's like an x and a y. You can't put the radical 2 with the radical 6 because they're different. They're not like terms. But you still need to put the like terms together and put all these radical 6's together. All right, so put the ones that are alike together. Let's see, negative 2 of these things minus 3 is minus 5 plus 2. Well, essentially these two just cancel each other out. And we've got negative 3 radical 6. You can have negative 3 radical 2 minus 3 radical 6. That's it. That's the answer. Now, you've got cube root of 6 plus cube root of 6. Don't get bogged down in the numbers. It's just 1 of whatever this thing is plus another 1 of whatever that thing is. So it's 1 of something plus another 1 of something equals 2 of that something. It doesn't have to be hard. All you have to do is recognize that we're just putting them together for a life. Next one, looks like we can add these two and get 2 of those things. But then this one's different. Number 13, we've got 3 of those things plus 3 more of those things plus 3 more of those things equals 9 of those things. Now, number 15. Number 15 is the hardest one so far. They don't look like terms, and they're not yet. But square root of 8, you may recall from yesterday or the day before, square root of 8, we can break that down. Square root of 8 has a square root of 4 inside of it. So really what we need to do with that square root of 8 is break it down. Square root of 4 is 2, so that's 2 times the square root of 2. Okay? Square root of 8 is 2 times the square root of 2. So really what we have is negative 3 times that, or negative 6 times the square root of 2. Don't forget to add on this 3 square root of 2, and now we're using like terms. So that's going to be the hardest part of this lesson is when you have to break it down. You have to recognize that first. Sometimes you can and sometimes you can't. Notice we haven't done this yet on any of the problems before. Now all of a sudden we're going to have to break down. but now we have these like terms. -6 of those things plus 3 of those things is -3 of those things. So when we look at a problem like 17, you need to ask yourself a question, can I break something down? That 20, can I break the 20 down? All right, and it's a square root. It's a square root, so you know the best thing that you can do is recognize that square root of 20 has a square root of 4 inside. All right, square root of 4, square root of 5. And you want to use a 4. Sometimes people will do something silly like try to say, well, it's 10 and 2. And that's true, 10 times 2 is 20. But I don't want to use that because I don't know either of those square roots. The whole point is to try to simplify it. And I can't do that one because I don't know the square root of 10 and I don't know the square root of 2. But I do know the square root of 4. And so the square root of 20 is 2 times the square root of 5. So this problem, -2 square root of 5 minus 2 square root of 5, put your like terms together, that's -4 times the square root of 5. Now remember the other method, if you don't recognize the number 4 comes out of a 20, you can still, break down the 20 like this. 20, I can divide by 2, that's 10, I can divide by 2, that's 5. That's 2 squared. That's 2 squared times 5. So if you had to do a square root of that, that's square root of 20. That's a root 2, and 2 goes into this 2 one time, so it comes out with no leftovers. And 2 goes into this 1, no it doesn't, so that has to stay. So you get 2 different methods. The fastest way is to recognize that a 4 goes into it. But if you can't recognize that, you can break it down using what's called upside down ratio. And that's probably what I'm going to use on the next one, number 19. It should be obvious to you, I think, that 48 is going to have to break down somehow. Okay? We want to break down that 48 somehow. And it's hard because we don't know fourth roots in our head very well. We know square roots okay. We don't really know fourth roots that well. So what I would do maybe on this 48 is let's break it down. I can divide by 2 and I get 24. I can divide that by 2 and I get 12. I can divide that by 2 and I get 6. Divide by 2 and I get 3. So 1, 2, 3, 4 2's and a 3. So I'm going to change that 48 into 2 to the 4th times 3. If you break it down in that way, it's not so bad to do a 4th root. I want to do a 4th root of that. Okay, now don't forget, there's a 2 in the front of all of that, but I'm just working on the 48 for now. 4th root of 48. So you can say that root 4 goes into this 4 one time, so a 2 comes out with nothing left over. And a 4 goes into this 1. No, it doesn't, so that's going to have to stay in. Now, all I've done is break down that 4 through to 48. I haven't done my terms yet. Okay, don't forget about this 2 right there. There's technically a 2 right there. And so that's 4, 2 times 2 is 4, times the 4th root of 3. Now we haven't even looked at this yet. So that comes down, we've got 3 times the 4th root of 3 minus 4 times the 4th root of 3. But now it should be easy because they're like terms. You got 3 minus 4 is -1. We're going to have negative 4 root of 3. And then the last one, I think it should be clear that you're going to have to do something with that 64. Right? They're not like terms. A 2 and a 64, they're not like terms. But we should be able to break down the 64. So, 64. I'm going to do it over here. 64. Divide by 2, that's 32. Divide by 2, that's 16. Divide by 2, that's 8. Divide by 2, that's 4. Divide by 2, that's 2. So 1, 2, 3, 4, 5, 6. That's 2 to the 6th power. 64 is 2 to the 6th power. So I just kind of replaced the 64 with 2 to the 6th power. I'm doing the 5th root of 2 to the 6th power. To me, that's way easier than looking at 64, because I could treat that just like I treated the variables in the last couple of lessons. My 5th root goes into that 6 one time with 1 left over. You're going to live like that. The 5th root of 64 is 2 times the 5th root of 2. All that's left is just to look at your like terms now. 3 times the 5th root of 2 minus 2 times the 5th root of 2 is going to equal 1 5th root of 2. All right, so again, I think the top half of this assignment is pretty simple because you just add the like terms. But once you get into the bottom half, you're going to have to start simplifying some stuff and then adding the like terms. All right, make sure to see me for questions. But get after it.